Okay, so what you did yesterday was how you can find initial values and figure out all the values in the ideal gas law. But more often, what's going to happen is you're going to have a gas and it's going to be acting a certain way. And then something's going to change. And when that changes, we want to see how it's going to affect the other values. So what you're going to see, this is a little bit more common. So today we're just going to practice how to figure out the little equation to solve for that. So if we are if we are changing pressure and we want to see the change in volume. So what we're going to do is just compare pressure and volume. We don't really care about N, R, and T. So when we say this, we can assume N, R, and T will stay the same. Okay, so when you do this, basically some of the variables are going to change and some of them are going to stay the same. And we don't care about the ones that are going to stay the same. So what we can do to compare these is we can actually figure out the pressure and volume of the first scenario and then the pressure and volume of the second scenario, and we can use that to solve. This gets a little bit tricky, so like I said, today we're just going to set up equations. All right, so let's see. So we have PV equals nRT, which we already know. I have it written up there. N times R times T, they're all staying the same. So this whole thing is going to stay the same. These are going to change. So the general rule for solving these is anything that's going to change, you push onto one side, and anything that's going to stay the same, you push onto the other side. Now, what we can do, we don't care about the stuff that's going to stay the same because we don't need to figure anything out. So our equation is going to be, to compare, it's going to be P1V1 equals P2V2. The 1 and the 2 just represent like the scenario. So, um, for instance, let me give you an example where you would use this. And we're not going to do the math for this, but I'm just going to write out a problem. So, a balloon has a volume of 0.55 liters at standard pressure of 1 atmosphere. Once the balloon rises, the pressure decreases to 0.9 atmospheres. What is the volume? So this is where we would be using a formula like this. So we're given a volume and a pressure, then something's changing. So when something changes, the pressure changed, so how does that affect the volume? So you would label these. This is the starting, so P1, V1 is going to be the starting amounts. So we're starting with this. This is volume 1, and this is going to be pressure 1. So those would go there. And then we have volume 2, or excuse me, pressure 2. And what is the volume? This is our question mark. That's what we're going to solve for. And then all we're doing is plugging everything in and solving the equation. But I'm not worried so much about this. We'll do this next week. I just want to see us set up the equations today. That's all. Okay? Now every single one of these, depending on how they're set up, has a name. This happens to be Boyle's law. Boyle's law is the comparison between volume and pressure. Okay, let's do another one. What if we want to compare volume and temperature? How does change in pressure Oh, I said volume, excuse me. Change in volume, affect, change in temperature. So, back to PV equals nRT. So that means, what are we focused on? We're focused on volume and temperature. Those are the two that are going to change. Pressure, number of molecules, and R are going to stay the same. This one's going to be a little bit harder to kind of rearrange, but so we want to bring temperature over to this side by dividing it away, bring it over with the volume, and then since pressure is one of the values that's not going to change, we want to bring it over to that side by dividing it away. So, in 2 steps we're going to do this. Divide out the temperature, and we're going to have, this cancels, pressure volume over temperature equals NR. All right, now we have volume and temperature on one side, which we wanted because those are the ones that are changing. Now we have to divide away the pressure on both sides, and this cancels. Okay, so we see that volume over temperature equals number of molecules times the gas constant over the pressure. Now, once again, these are your ones not changing, so this is going to stay the same here. So essentially, we don't care about that. So when we set up the equation to compare volume and temperature, it's going to be volume 1 over temperature 1 is equal to volume 2 over temperature 2. Once you set this up, this is known as Charles' law. I'm not going to have you memorize those, but just so you know, each comparison has a name. That's all. All right. So I'm going to have you try a few of these. You get the ones that are changing to one side, get the ones that are staying the same to the other side, and then you set it up like this. Okay? It's going to be a little bit challenging, but like I said, it's okay to, I'd rather you try it, make a mistake, and then we can kind of see where we're going from there. So don't get too worried about it. Once we master this, then we will actually plug in some values and compare some things. Okay. Check the questions. There's just going to be 1 or 2 of them, so not too many of them. All right, thank you.